All right, let's dive right in. Today, we are pulling back the curtain on a core piece of how the internet actually works, layers 2 and 3 of the OSI model. Now, I know that sounds super technical, but trust me, it's not. Just think of them as your own personal digital postal service, the unsung heroes making sure every single thing you do online gets exactly where it needs to go. So let's start with a really basic question. You click on a link, right? How in the world does the data from a server, maybe halfway across the planet, find your specific laptop and not the one sitting right next door? It feels like magic, but it's not. It's actually a really brilliant two-part system. And here's the best way to think about it: the digital postal service. Layer 2 is like your friendly neighborhood mail carrier. His only job is to get a letter to the right house on your specific street. Simple enough? But Layer 3? That's the global logistics expert. That's the system that figures out how to get that letter from a post office in, say, Tokyo, all the way to your local town. They have totally different jobs, but you absolutely need both. So let's zoom in on that local postman first. We're going to focus on Layer 2, which handles literally everything happening inside your immediate local network. Think of your home Wi-Fi. Okay, so its official kind of techie name is the data link layer. Its entire world, its whole universe, is just your local network. It moves data around in these little chunks called frames. You can just think of frames as the envelopes for your local mail. They make sure data gets from your laptop to your router or from your phone to your smart TV, all within the walls of your own network. And here's the key. The way Layer 2 finds anything is by using a very specific address called a MAC address. Every single device that can connect to a network, your phone, your computer, your game console, has one. It's a permanent serial number that's burned in at the factory. So in our analogy, the MAC address is the unique house number on your mailbox. It guarantees the mail gets to you and not the person next door. This means when you have a Layer 2 problem, it's always a local issue. The postman literally can't find your house. This is your classic is it plugged in problem. You know, a loose Ethernet cable, your Wi-Fi suddenly drops, or maybe you accidentally turned off the network card in your computer settings. These are physical, local things that stop those data frames from even getting out the door. Okay, so that's local delivery. Pretty straightforward. But what about getting data from that server in Tokyo? For that, we need to zoom way out. Let's shift gears to Layer 3 and talk about the global journey. And this is the network layer. Its job isn't to deliver within a network. Its job is to move data between different networks. It takes those local frames we talked about, wraps them up into something called a packet, kind of like putting a letter into a bigger parcel for international shipping, and then it acts like a super smart GPS, finding the absolute best, most efficient path across the entire internet. Now, to navigate this huge global system, it needs a different kind of address, the IP address. And here's a crucial difference. Unlike that permanent burned-in MAC address, your IP address is temporary. It's logical. It's assigned to you by your network. It's like your full mailing address: street, city, state, and most importantly, the zip code. It's what tells the global postal service which country, which city, and which neighborhood to send your package to. So the problems at this layer are more like big logistical headaches. You know, the package has the completely wrong zip code on it. That's basically a wrong IP address. Or maybe your local post office has no idea how to send mail outside of your town. That's what we call a missing default gateway. Without that gateway, your data is just stuck. It has no idea how to even begin its journey out onto the internet. All right, we've got the local postman and the global navigator. Let's put them side by side to really nail down the differences between them. This table really puts it all together, doesn't it? Look at the scope. Layer 2 is all about what's happening inside one network, using that permanent physical MAC address. But Layer 3, it's all about moving between networks, using that temporary logical IP address. It's that local versus global distinction. And that's why their problems are so different. A physical problem, like a cable being unplugged, versus a logical one, like a bad route somewhere on the internet. The main takeaway here is you need both of them working together perfectly. Okay, that's enough theory. How about we stop talking about it and actually see it in action? Let's roll up our sleeves and look under the hood of your own computer with a quick mini lab. So if you're on a Windows PC, go ahead and open up the command prompt. Then just type in this one command, ipconfig, a space, and then /all. This single command is like a secret key that unlocks all your network info, both local and global. Once you hit enter, you'll see a bunch of text. Just scroll a bit until you find your main network connection. You're looking for 2 lines specifically. Where it says physical address, boom, That's your permanent Layer 2 MAC address, your device's serial number. And right near it, IPv4 address. Well, that's your temporary Layer 3 IP address, your current global mailing address. They're right there, on your own machine.
And hey, want to troubleshoot like a pro? It's a simple two-step test. First, try to ping your default gateway. That's just your router's IP address. This is a Layer 2 test. It's asking, can the local postman even get the mail to the end of my street? If that works, great. Now try to ping 8.8.8.8, which is a public Google server. This is your Layer 3 test. It's asking, okay, can my mail actually leave town and travel on the global network?
But here's my absolute favorite command for seeing Layer 3 do its thing. In that same command prompt, I want you to type tracert. That's TRACERT, and then a space and www.google.com. It stands for traceroute. What this does is literally show you the entire global journey of your data packet, step by step. Each line that pops up is a hop, a different router your data is visiting on its way to Google's servers. You can actually watch it travel from your home router, out through your internet provider, and across different networks all over the world. It's a real-time map of Layer 3 doing its incredible job. You know, after all that complexity, the addresses, the routes, the different tests, it all comes down to one simple number, 2. It takes 2 distinct layers working together in perfect harmony for you to do anything online. The local postman and the global navigator, every single second of every single day. It's a system that's as elegant as it is powerful. So now you have the tools. You can see your own addresses, you can test your local and global connections, and you can literally trace the path your data takes across the planet. The only question left is, where are you going to trace your data to next? What digital journey are you going to explore?